Imagining you, I do. I think about you day and night. It's only right to think about the girl you love and hold her tight.
Welcome to Crazy Carrot Studios. My name is James. Today I will be going over with you the basics of understanding and writing scripts inside Unity. While this is not a tutorial about how to navigate in Unity, throughout these videos we will cover details about Unity and how or why our scripts are communicating with them. Having at least a very basic knowledge of how to maneuver inside of Unity will be helpful but not necessary. As I go through the steps, I will do my best to explain what keys I am pressing so that you can follow along. The first thing we will cover is, what is a class? Classes are the blueprint for your objects. Basically, in Unity, all of your scripts will begin with a class declaration. Unity automatically puts this in the script for you when you create a new C# script. This class shares the name as the script file that it is in. Next, what is a variable? Variables are the building blocks of code. When building a game in Unity, you often need to store information, such as a player's age or the current time. Variables are perfect for storing data. And lastly, what is a function? A function is a way of wrapping code so that we can reuse it whenever we want. One thing to understand about code in C# is that the code is executed in the order it was written. Now that we have a basic understanding, let's dive into Unity. Go to the Unity Hub and let's create new project. Inside of our project, I'm going to be using 2021.3.16F1. I'll be going to 3D URP, which is Universal Render Pipeline. I'm going to be naming mine Learning with Bob, but you can name yours however you prefer. Going into Unity, there are a couple different layouts that you can use. I'm going to be using our default layout, but you are welcome to use any layout you like. Go to your top right and select whichever one you want. Now let's go to our Assets folder, and we're going to create a folder for organization called Scripts. So we're going to right click on Assets, and then you're going to go to Create, and then go to Folder. From here we're going to title our folder Scripts. And then in the empty area, we are going to right click, go to Create, and go to C# Script. Now that we're here, I'm going to call this Testing. You can name it whatever you like. Once you set the name, it will compile, and you will be opening it up. And I use Visual Studios. You can use any editor that you would like, but I do recommend using Visual Studios because communication with its IntelliSense and Unity allows for easier programming with Visual Studio's hint system, IntelliSense. And a public class testing, so it's basically your name. The name you gave your script is also going to be the title of your class. Now it's going to inherit from MonoBehavior. Now MonoBehavior is the base class from which every Unity script derives, as you can see in the highlighted area. MonoBehavior is the backbone of Unity that allows you to communicate with the game engine through your scripts. Now these here are the functions to start and update. They are derived also from MonoBehavior, so those are the functions they created, not us. So we're going to delete these for right this moment. And we're going to start off talking about variables. As we were talking about before, variables are the building blocks. They are your data storage. This is how you define what everything is going to be about. There are many different types of variables. We will try to go over a few of them. The first thing you need to do is define whether it's going to be a public or a private. Private will not allow you to access it from any other script or the inspector, whereas public will. We're going to start off with using a simple int. In this particular case, we're going to call this int age. Now an int can be anything that's a whole number. So as long as it doesn't have a decimal or a fractionated symbol, then an int will work for anything like that. Next, we're going to show you what a private is going to look like, and we're going to call this one, let's say, year. Now again, we're just setting it up. I'm going to show you what it's going to look like in the inspector after you save it. Let's go ahead and go down into Unity, and you'll notice that the private is not going to be shown. Now, first thing we're going to have to do is we're going to have to create something to have this sit on. So let's go into our plus, go create empty, and it's going to give us an empty game object with nothing on it but the transform. We'll go over the transform a little bit later, but basically it's going to tell you where it's sitting inside of Unity. Now we're going to drag this testing straight into our game object. Now there are other ways you can do this by going in here and searching for testing, or create a new script straight from that component and name it at that point, and it'll automatically have it attached when you do it. For now, we've already got it dragged on, and you notice that the age is showing, but the year is not. Now, if we go back into our C# script and change this back into public, and then save it, we will go back into Unity after it compiles, and you will notice that now year is being shown. Now this will allow us to set a variable value to these when they are public inside the inspector. If it is private, you're going to have to hard code it inside the script itself. Now there are ways to do a serialized field in this particular case to allow you to see what a private variable is inside the inspector, but it will still remain private to any other script. Now you notice here in Visual Studios, it automatically allows us to see a hint of what we're trying to do. Now we're going to change this back to private and then save it, and you will now notice that we are able to see the private variable in Unity when we go back in there. So let's go ahead and save this value and then go back into Unity. And again, before when we had it private, you weren't able to see it. Now we can still see it. Let's go ahead and set a value for this one, and let's say we're partying like it's 1999, we're 21 years old, yay, and let's go from there. Now, these are values that can be changed at runtime at any time, depending on what you're looking for. So now all of a sudden, it's 2023. I'm 41 years old, boo. So as you can see, because of this, it gives us flexibility to set our variables to whatever value we need at that moment. Now, if it's private and you have to hard code it, you lose that flexibility. Let's go ahead and go back into our script. Now that we understand what a little bit about public and private, let's show you some different variables. The next one we're going to go over is going to be a public float. You want to look at a float like a fraction. It's a number with a decimal behind it. This will enable you to set, let's say, a timer that's ticking down, and typically with a timer you're going to see not only the minutes but the seconds. So this will give you the fractionated number, and whenever you put it into form here, you need to put an F behind it. That allows Unity to know it as a float. Now, a float gives you a lot more flexibility than an int, but it can do a lot of the same things because it does have whole numbers involved in it. Whereas an int, if you went and tried to give it a decimal behind it, and you try to put it, it'll have an error. Now that's Visual Studios telling you, hey, Unity has a problem with this and we need to correct it. So let's go ahead and take that back, and we're going to keep it as an int, and then we can see the difference between a float versus the int right there. So as you can see, float just gives you a little bit more flexibility. Okay, now that we know a little bit about ints and floats, let's try giving us a new one, and we're going to do a public string. Now, a string is a length of text. Any collection of keyboard characters can make up a string. Usually you will put these inside quotation marks, and that's what's going to allow it to separate itself from other objects or other variables. On this string, we're going to call it Bob, because why not? Now from here, we're going to go ahead and save it and go back into Unity, and you notice that our string does come up here, and it gives it the name Bob. Now the other ones didn't change because we've already changed it in the inspector, but Bob is there because it was hard coded in. Now we can change it at this time. Let's call him Robert, and you can see now it's got holds a new variable value. Okay, so now we've gone over ints, floats, and strings. We get a basic idea of what variables are going to be able to do, both public and private. So let's get rid of all this and let's start working on creating our own functions with our own variables that can work together. Now, if you remember right, when we first started off with our script, we had some functions that are already established. One of them was start. That is a mono behavior function that allows us to communicate with when the Unity starts. So we're going to create another start, and you notice here it's got private. If we were to say that public, then other scripts can access it. Now with private means other scripts cannot. Now start is usually always private, but when we create our own future ones, we will make them public in a lot of cases. So we're just going to start with a new variable. Now in this particular one, we're going to call it an int, because we're going to keep it at a value of 1. So let's call it 1. Now we're going to make this value equal 1 as well. Now this is going to set it hard-coded, but when we go back into the inspector, you will be able to change it if you wanted to. Now let's go ahead and create another public variable, and as you may guess, we're going to call this one a public int as well. So public int, and why not call it 2? We're going to give it a value of 2. Make sure you add the semicolon because that ends your statement. And then we're going to give another private one. We're going to change it back to private and call it an int. And we're going to give it a value of total value. Now, typically what you want to do on a private is make sure you put an underscore in front of the variable name. When it's public, you don't need that underscore. Now this makes it universally easy for you to see it when you're looking through your code to find what is private and what is public. This is something that most programmers will do, and so when you're sharing your project, they understand as well that the underscore makes it private. So let's go ahead and make this total and then value. Now this is where camel casing is going to come in. Camel casing is a standardized practice as well because it'll allow you to see the first name, the lowercase letter, to be capitalized in Unity, and then a space will be given between the last lowercase and the capitalization. So in this particular case, value 1, the V will be capitalized, and a space will happen between E and O. So let's go take a look at that inside our Unity inspector by go ahead and saving. And let's go back into Unity and see if it does give the space and the capitalization where we said it would happen. And this is why we do camel casing. Notice the V has been capitalized and a space became between the two names. So when you do this, Unity understands that it's 2 words, but because you want to keep yours as a 1-word naming convention, this makes it a lot easier. Now this here, we're going to go back into the private function that we have called start. So whenever we press play at the start of the game, it's going to fire off everything that's going to be between these brackets. Now another thing that you're going to do a lot of times that will save you so much headache when you are trying to understand where a problem is, we're going to use something that's going to be called debug.log. This is going to enable you to be able to test things out to see, okay, is my function being read? Is it firing off what I'm trying to get done? And allow you to see this in the console of Unity. In this particular case, we're going to go ahead and try to explain what we're going to see. So we're going to say value 1, and then we're going to make sure in quotes, we're going to give it a plus sign with spaces on both sides. This will allow, when you read it in your console, to actually be able to see what you're looking at and give it a space between the two instead of having it all run together. Now because you see the squiggly line, that's because we don't have a plus before this quote. Now the quotations are the variable that we're putting in, to telling it what we need to see. The value 1's already got a value. The quotation marks gives it the value of a plus. Then we're going to add the second value, which is value 2. And then we're going to want it to equal, but we need to put that in the quotes as well. We want it to equal total value. Now, obviously, we haven't defined what total value is at this moment, but we are going to show you what the debug log is going to look like when you go ahead and save and we go back into Unity. So what this is right now is going to say is value 1 plus value 2 equals total value. In a lot of ways, it's like your old math class when x is equal to 1, y is equal to 2. Well, x plus y is going to equal z, which is total value. So in the end, we wanted to calculate the 3. So we're going to show how that's going to be done in a minute. But for now, let's see what debug log does with this right here. Now, as you can see, we've already got value 1 set for 1 and value 2 set to be 2. So when we go to play and we go to console, you'll see 1 plus 2. So that's value 1 plus value 2 is equal total value. Now, because total value has not been giving a value, it's showing us 0. So let's go ahead and go about giving it a value. So what we're going to do is inside the start menu, right above the debug log, let's define what total value is going to be. So underscore total value, which is our naming convention for the private int of total value. And we're going to say that it is equal to value 1 plus value 2. Pretty simple math. Now, this is about the easiest you're going to see, because as we go through other functions, it's going to make a little more sense as we go through them, but they are a little bit more complicated than this. But this is about the simplest way I can explain how the function is creating whatever codes you're running and firing it all off inside the brackets. So now we're running two pieces. One is total value is equal to this, and then we are trying to read that total value by saying debug.log value 1 plus value 2 and putting it in a way that we can see it visually. So we've done both. Now let's go ahead and save this and let's go back into Unity. We're going to replay again, let everything compile. And then now when we hit play, you'll see 1 plus 2 is going to equal 3, and it's in a format that we can understand. That's why we did the quotes with spaces between it so they don't run together. So this is where we're going to leave off for today. In our next one, we will try to create a game object, probably a cube, and see how we can get our script to interact with that cube using what we've learned today between variables and functions. So from all of us at Crazy Carrot Studios, I say thank you and hope to see you again.
The skies